All right, so when we talk about growth and decay, you are fairly familiar with the formula and what it looks like when we graph. When we do application type problems, meaning word problems where we apply what we know, we have to kind of set it up so that we can plug in those values given to us. So for growth, our formula is going to be A times 1 plus R to the T. So I need to tell you what everything stands for. A is going to be your initial amount. R is your rate, but now your growth rate, it's going to give it to you as a percent. It's going to say that population increased at a rate of 6.23% per year. So you need to make sure when it gives it to you as a percent that you change to a decimal for the problem. And T is your time, and most of the time your time is in years. I won't say always because sometimes we'll do bacteria multiplying maybe every 30 minutes, or with decay, maybe something that has a half-life. Y'all have probably learned about that in chemistry. So every 2 minutes, it's cut in half.
I have not learned anything.
Okay, well, in general, it's years, but it can be any unit of time there. All right. Together, the 1 plus R we call the growth rate. 1.
1?
That's a 1.
I thought you said L.
1.
Why put L?
Okay, put 1. That's not L, put 1. And so I give you decay and growth together because they're so very close. Decay is the same thing. It's 1, not L. Thanks. 1. Minus R this time to the T, and everything stands for the same thing. Pause.
Yes.
There's a zombie apocalypse. We start out with 5 zombies. Zombies are increasing at a rate of
10 per day.
Let's do a growth rate, though. Let's do a percent. Let's say 20% per day. So that's one of them each day bites somebody else. Okay? How many zombies, and this time I'm switching my time to days instead of years. How many zombies are there after 30 days?
35,000.
Right.
So is it
The first time it would be 20% of 5. Then it would be 20% of 6. Then it would be 20% of, so yeah. So 5 times raised to the 30th.
Yeah.
Since it's raised.
This
is decimal, you put it in as 0.2.
Yes. You have to change it to a decimal in order to work it in the formula. So how many zombies are there in 30 days?
1,186.
1,186.
Wait, so what you have growing is the A? Like the
That's your initial amount. That's what you started with. We started with 5. Only 20% infected people each day. So after 30 days, in 1 month, you now have 1,186 zombies.
So Miss McGee, since you just did that, we could be a zombie farmer, and that's like half our work.
Ben. So if you think about this, my asymptote is at 0 and it's increasing, so it starts to increase more and more as I go. It's exponential growth. Okay?
And when they use this, you would round down from whatever number you get.
Yeah, because I would say you can't have a piece of a zombie, but technically, no. But yes. All right, let's do a decay. Let's see. What's something you can think of that decays? What? I'm thinking a car. Is what y'all are thinking, like things that are breaking down and decaying, and I'm thinking about decaying in value. So let's say, I'm sure you've heard your parents say before, when you buy a car, as soon as you drive it off the lot, it's not worth what you paid for it anymore. Okay, so let's say you paid $26,500 for your, okay, $27,500. Oh my gosh, you got me. $27,500 for a what?
Ford F-150.
For a Ford F-150. Paid too much. Okay. Let's say that I told you that Fords decrease by 12.5% each year. Since this truck's got to get you through the rest of high school and college. Most of us are what, sophomores?
For $27,000, my dad would not pay that much for that.
Which is irrelevant.
My dad wouldn't even pay like $500.
Okay, Max, this is a hypothetical situation just so I can model the formula for you. Okay, so 2 years of high school, 4 years of college, that's 6 years, 2 years grad school, 8 years. 8 years, let's say 8 years. What is this truck worth in 8 years? Calculate it.
69.
Well, it is a Ford.
Hey.
Fix or repair daily.
Thank you God for it.
Calculate it. What is this $27,000 truck worth 8 years after you buy it?
So if that would be a 2000 it's 28.
Damn,
9,450.
Dang,
How many years?
Wait, so what do? You
Just plug this in your calculator.
I'll tell you what, the things that hold the most value are Toyotas.
Okay, Ben, let's stay on track and match. Alright, here we go. Questions about basic growth and decay. This is very, very basic. I'm fixing to show you one that's not quite so
write
basic.
polygang on your board?
No, can you be quiet? Okay, let's talk about interest.
Oh my gosh, Miss McGee. One time when I voted for my
Ben, let me ask you this, Ben.
It's about interest.
If you take $50 to the bank, and you put it in the bank today, and they tell you they're going to pay you 5% interest, and they tell you, that is really good, that's not, but let's say they tell you they're going to give you 5% interest each month. How much do you have after the first month?
Alright.
You took $50.
So they pay you to use the
So you
bank.
gotta get that,
They in a way pay you to use the bank.
Yeah.
plus.
It's only a certain account for savings, right?
When you have 75.
Oh, wait.
Some checking will do it. But yeah, savings are usually. Alright, Ben's figuring out he walked into Safe Federal Credit Union with $50. Exactly, $250 is the amount. Okay. Alright, listen, guys, I need your attention up here because you're going to use this for your project, and if you don't know how to do it, you can't do it in your project, and if you don't know it, you can't do it in your homework either. Okay, so end of month 1, and we're just doing a monthly rate. End of month 1, you have $52.50, do you agree? Okay, so month 2 rolls around. You're still getting 5%. Do you make 5% on your $50 or do you make 5% on $52.50?
$52.50.
So that's what we call, that's a concept called compound interest. Okay? It's interest on interest. You're making money on money you didn't put in there. Do you agree? Okay. That's compound interest.
So theoretically, you don't even need a job. You can just make money off your money that you get.
You make nothing.
$250 a month.
Interest on
Well, if you have that many,
interest.
if you have like 400.
We have a slightly different formula for compound interest than what we have for just growth, right, Matthew?
Miss McGee, one time when I was little,
No time. It's so funny. Man, I gotta tell you something. When I just show you something.
one time I finessed my sister.
Okay. So this is a little bit different. You'll notice a new variable in here. What is that variable?
Oh my gosh,
An N. Okay? What that N does is that N tells us how many times the interest is compounded per year. So, let's...
Like if it were monthly, that'd be 12.
Yes, exactly. Number of times compounded per year. So, if we said monthly, Matt said that is 12, and he's absolutely right. Okay? If we said that it was compounded quarterly, 4. If we said that it was compounded...
2 quarterly.
What?
Timely.
Weekly.
52.
Daily.
365.25.
Okay, we're going with 365. The bigger that these numbers get, okay,
More guac you make.
the closer it gets to being compounded what we call continuously. Compounded continuously
Dude, I'm so hungry.
looks like this, okay? My A, this is the most common, the most real life formula is PERT. Why is that funny? Oh my goodness. There used to be a shampoo called PERT. Okay. The only difference here, P, this is still my initial amount, Matthew and Ben, y'all are stressing me out. P is the initial amount, R is the same, T is the same, and E is that variable, that irrational number that we just learned, okay? So I'm gonna do an example with you. Thanks.
Wait.
R and T is the same thing. It's your birthday. It's your birthday.
It is my
It is your birthday. Okay, Matthew. Does anybody give you money for your birthday?
Yeah.
Okay, so give us a rough estimate. How much money are you gonna get for your birthday?
$100.
$100. You decide to take that $100. I'm gonna guess you're going to First Palmetto. Okay. You take it to First Palmetto. And you tell them that you want to put it in their best money-making account, your best interest. And they tell you that there's 2 you can choose from. You can choose one account A that is going to compound weekly at a rate of 3.5%, or you can put it in one that's going to compound continuously at a rate of 3.2%. And so you want to know which one's going to give you the best return. Which one are you going to get more money in? So what you want to do, let's do the same 8 years we started with before. Okay. How much is in there after 8 years? 8 years.
What's continuously? How do you do that one? Yeah.
All right, so these are the 2 different formulas, all right? I've got my A times 1 plus R over N to the NT. And this is, you're going to have to be very careful as you put that in your calculator. There's a lot of places to go wrong there. Continuously is my PERT.
Oh, yeah.
I was going to say, y'all were real... Thought that was very humorous when I put it up here, and all of a sudden you forgot what it was. All right. So set it up, see what happens. You work through it on your paper, and then we'll come back together and do it. As y'all continue to work, I've got the formula here. Don't look up if you haven't got it yet, but I've got the formula filled out up here. I'll do it for this one also. But the hardest part about this is plugging it in correctly on your calculator. Because you've got a fraction here and you've got multiple things going on in your numerator. So, in your exponent, excuse me.
I'm very confused. Wait, so do you plug in?
Okay, where are you very
like
confused?
the E or like the
Let me
X?
pause. That's the. All right, I'm gonna plug these in for you so you see. If you are a plug everything in at one time kind of person, guys, if you're talking while I am, you might be hindering someone else from learning. 1 plus, remember fractions go in parentheses, so I got 0.035 divided by 52. I close off that fraction, but then I also have to close off the 1 plus parenthesis. Now I'm going to raise it to, and because I'm doing something in the exponent and I want to keep them both in the exponent, I need to put parentheses around that before I do it. So 52 times 8, close parenthesis. I have $132.30 after 8 years.
For a copy.
Wait, is that added to
Well,
the
That's part A.
Is that added to the one?
Part A.
No, that is your total amount.
What did I do?
And that's actually a very generous interest rate. You're not going to find interest rates that high for like just a regular savings account. All right, so now let's do the PERT. 100 E. This time is 0.032 times 8 years. What's the better option? A.
Told
Okay.
y'all.
The closer, although continuously sounds like it would be so much more, it's actually getting closer. The more times you compound it each year, it's getting closer and closer to being continuously compounded. So weekly is a pretty good, yeah.
I plug mine if I could without the extra parentheses and still give you the same thing.
Okay, just be careful. Does yours bring it up as an exponent automatically? See, mine doesn't. You see how my exponent doesn't bring it up here.
No, I'm talking about like within, like with the 0.35.
It's because your exponentiation is different on your calculator, so it's going to bring everything down here raised up to a power anyway. If I'd have done it, it was a little bit different.
This is an interest
Different
like
account.
realistic interest, like